Alright guys, welcome to another video, and today we are focusing on the x-axis. Remember that the last video we actually focused on the y-axis. Today we're going to be focusing on the x-axis. Now, if you have not watched the video series on the y-axis, I would advise that you go now to watch the y-axis. And if you have not watched the introductory video about when I first built this machine, I want you to also watch that so that you can see that the machine actually works perfectly fine. All I'm doing here is I'm trying to help you now to see how it works and how you also can build your own. And even if you are not interested in building, you can watch this video to at least understand why your machine functions the way it does. And so that if something goes wrong, you can know what to do about it. The same principle applies here, whether you are using an Ender 3 or you are using a Voron or whatever it is you are using. The only difference is that there are certain types of 3D printers that are common with this method, right? So all 3D printers are not built the same, right? Core XYs obviously don't look like this. These are basically Cartesian types of 3D printers. So you may not be able to use this across board, but you see, they still share certain similarities with each other, such that you have an x-axis, you have a y-axis, and you have a z-axis. So for as long as those things hold true, this video can help you. So let's quickly get into it. So now, I remember I told you that the y-axis, the primary job of the y-axis is to handle the plate, that is to control the plate. Whereas the primary job of the x-axis is the one that holds the hotend. Now, the hotend is not the question for today, it is the x-axis itself and how it was set up, right? I remember in the last video I also made, I explained why we create motion systems the way we create them. The purpose of motion systems is so that your motor readings can be taken by the board and of course subsequently the software that you're running on it, which is Arduino. So what's happening is that we have a motor that is installed on this machine. The motor is really the printer. It's like almost nothing else is the printer in this case. It's the motor, because the motor is what's doing the motion, right? So the motors are like the most important part of a 3D printer. So any gantry system, any profile system, any setup we're building it for the simple reason that the motor can efficiently move. So now the x-axis was built with that in mind, right? The purpose of the x-axis is to allow the motors here to control the hotend. Of course, what I said a bit here when I said the motors are the machine, that is an oversimplified way of saying it, but that's basically it, right? The motors are the most critical component of any 3D printer, of any device that moves, as a matter of fact. Because once you can take the reading of a motor, you can manipulate it with a board like Arduino and then codes like Marlin. Do you understand where I'm going? Where I'm going? So keep that in mind. So the x-axis therefore is serving the same purpose like the y-axis is serving, to aid efficient motion of the motor. So this motor now, if you look at this place now, you'll see that this motor is actually connected. You can see that motor at the back there, right? So this is the pulley of the motor, and this belt actually runs through that pulley, right, and runs across the x-axis all the way to the idler pulley on this side. Do you understand? So essentially what we are trying to do is like a hanger. We're looking for where to hang the motor. Do you understand? So we need a rigid structure that can house the motor. That's essentially what we're trying to do here. There's nothing really special that we're doing when we are constructing any profile or any motion system. It is that we're trying to take reading from the motor. Do you understand where I'm going? So I'm going to show you the basic components of this motor now, and of this x-axis right now, so that you can see it in case you're trying to construct yours. You take cues from what we devised here to make it work. Now, like I was saying, right, the specific choices we made here are very subjective. So which means when you're trying to build your own, you don't have to use this specific setup. So that's why you have to pay attention to the concepts, not what we used. If you take what we use now, what if you don't have that part in your country? right? So you have to understand the basic concepts, and the concepts are simple. We want the motor to move. That is the purpose of any motion system. We want the motor to move effectively, right? So what is the best way to make the motors move effectively? So in the first case, to hang the x-axis, we needed the profiles, these straight profiles. So that's why 3D printers always have that straight profile, because that straight profile is where we hang the x-axis, right? And then the x-axis always goes in consonant with the z-axis. In this current setup now, you see that the y-axis is the only one floating by itself. But on the x-axis, especially in this particular type of 3D printer, the x-axis is always attached to the z-axis. And the purpose is that when the x-axis is moving, right, the z-axis also can lift it up. Do you understand? So you see that the z-axis is connected to this x-axis by this particular threaded rod. Do you understand? And we connected it in two sides. We connected on this side, we connected in this side as well. If we connected it to only one side, then the machine is going to sag this way, right? And if it sags this way, your print is going to look awkward. It's not going to make sense, right? So we want balance along the x-axis, not just for motion. So the imbalance of the x-axis does not concern the x-axis. Actually, the z-axis that has that problem. But you see, if the x-axis is not especially straight along the z-axis, you're going to have a problem with the quality of your print. So you see that your print will just bend on one side. It's not going to be flat like this, just bend like this, because the z-axis itself is bent. And so the x-axis, even though it will still go along its own plane, will require the position of the z-axis to be able to define its own positional movement. Now, to make the x-axis work in this particular setup, we decided to hang it using these balls, right? These balls are like bearings, and you see we had 2 for each pole and then another 2 for each pole. Trust me, this is not the most tidy setup we can use, right? While I was building this thing, I just wanted to get things going, right? I didn't really understand what I was doing. It took me until I had finished it that I was now understanding, oh, so this is the purpose of why we're doing all of these things, right? What we're really trying to do is that we want the x-axis to stay, attached to the z-axis. And so to achieve that, we decided to use these tires, right? You can get these tires for cheap anywhere, right? If it is not in your country, you can contact me. I can sell them to you, or if you know where to get it by yourself, you can also get it from China by yourself if you want to, right? So these particular tires now are kind of like the tires that clip to the z-axis, right, which is this beam, right? And then it clips on 2 sides. So now, like I said in the previous video, if you look at some other machines like Bamboo, for instance, Bamboo uses linear rails for that same place, right? So let me show you what that looks like. So if you look at Bamboo 3D printers, right, they prefer to use this particular linear rail. And in that case, it means if we use this linear rail, we are not going to use these tires, because these tires now and this linear rail are doing the exact same function. They are helping you glide along the x-axis pole without effort, right? So it is effortless glide along these 2 poles that these particular tires are for. Once these tires can glide effortlessly, then we don't have a problem. Do you understand? So in that case now, if you were supposed to use a linear rail instead of these balls now, for instance, it means you are going to have to attach the linear rails to this like this, right? So it's going to run all the way from down and attach to this place, so that this 2x2 mm frame will then attach to this side, and then you have this same thing on this side as well, so that you have attachment on this side and attachment on this side. Do you understand? But in this case, I had to use balls because, number one, I didn't really know what I was doing. So maybe when I re-upgrade this machine, I'll probably just use a linear rail, do you understand, to attach it. Do you understand? So the x-axis can actually be mounted to the z-axis without using these particular balls. So keep that in mind. It's not compulsory that you must use this exact setup. So that's one thing you have to put into consideration. Again, you could also have attached the x-axis to the z-axis by using a linear rod. So in that case, when you use a linear rod, you are going to need a bearing. If you use this linear rod, this smooth linear rod, right, you are going to need this linear bearing because you need something to glide over, right? So what this and this are doing is that they are gliders, right? They help you to glide. This one is gliding like a tire. This one is gliding like a rail on a train track, and this one is gliding like a rail on a train track. It's just that it's using a bearing. What are the pros and cons? There's no pros and cons. It just depends on what you want to do. I've seen high-end printers use all three of these, right? Do you understand? So it's not like you have to particularly use this particular setup. No, it's just that you have to be creative with what you want to do and then how you do it. But if you don't even understand what you're doing, I think any one of them is fine, right? I think any one of them is fine. It's not compulsory that you use this. And I remember the last time I was talking about the y-axis, I also did tell you that you also don't have to use an aluminum profile. It could have just been stick, right? You could have used wood like I did here, right? So you don't have to use this particular aluminum frame. But if you want something that looks neat and looks classic, of course, the aluminum profiles look classic. But you see, every time you are using an aluminum profile, you have to start thinking of brackets. Whereas if you used wood, you'll have to be thinking of screws and all of that. So to set up on a wood is much easier because you can do a lot of DIY with wood that you probably may not be able to do with an aluminum profile. But should you try to use an aluminum profile, it's perfect. It's just that you have to use a specific kind of aluminum profile, which cannot fit into the scope of this video, so we have to reserve it for another video. But don't forget that the x-axis will not stay straight like as it is now if you don't have this linear screw, which is another method you can use to make your machine work. There's some machines that use linear screws, but it's not very common to use linear screws for y-axis, nor is it common to use it for the x-axis. But some people might want to get creative. It still does the same things, right? So now all of these are fasteners. It just depends on which fasteners you pick. Now, having fastened the x-axis to the z-axis, we have now been able to put a scenario where the motor's reading can be taken effectively. So now, how do you then connect the motor to the thing that the motor is carrying, which is the hotend? You use a belt. So in most cases with 3D printers, you'll always find belts. The belt is usually the connector between the motor and whatever it is that you are trying to drive. On the y-axis, we are trying to drive the plates. So we connected the plate's bed, that is the thing at the bottom that is housing the plate. We connected it to the motor using a belt. So also on the x-axis, we connect the x-axis carriage, which is the one holding the hotend. We connected it using a belt as well. And very crude setups here. Just one long screw, and then we attach it to a belt on this side, and then one other long screw here, and then attach it to another belt. I will make sure it's tensioned a bit, right? The tensioning matters a lot. In this video, I'm not going to cover tensioning, but the tensioning matters a lot if you want a print that looks sharp and not wobbly, right? So as far as I'm concerned, that's pretty much what you need to put into consideration when it comes to fixing your x-axis. It's not a lot of complicated setup. It's two things you have to put into consideration. I have to house my x-axis permanently on my z-axis. How do I do it? I can either use balls, bearing, or use linear rods, or use linear rails, right? Whatever choice you use depends on whatever outcome you're looking for. Nobody's going to tell you what you should use, but the only important thing is that your x-axis must be able to attach permanently and rigidly, and your motor will be able to move efficiently. And I think that's pretty much it. Once you are able to move this and nothing is falling off, you have done a perfect job. So that's pretty much all you need to know about the x-axis. I hope this has helped you. If it has, I want you to hit the subscribe button, hit the like button, turn on the notification bell, and I'll see you in the next video. Bye bye, take care.